Hello friends, welcome to Study Studio YouTube channel. Today we are gonna see a important derivation for class 12th on the balance condition for Wheatstone bridge. Here we have a diagram consisting of 4 resistors, namely R1, R2, R3 and R4. We can see that they are connected across the arms or joints A, B, C, D. Here we have two junctions A and C which are connected to the battery, hence this is known as the battery arm, and B and D are connected to a galvanometer, hence this is known as the galvanometer arm. First let's apply Kirchhoff junctions law for junction B and D, from which we come to know that I1 is equals to I3 and I2 is equals to I4. This is true because there is no current flowing through galvanometer, because as the Wheatstone bridge is already in balanced condition, hence it's not no current is flowing through galvanometer. Next, applying a loop law for A B D A loop, we get to see that the changes in the potential across any loop, we come to know from the Kirchhoff's loop law that the changes of potentials across any loop in a circuit involving cells and resistors, the total potential change, the sum is equals to 0. Hence, applying that law for the loop A B D A, we get negative because current and the current flowing in the loop is in same direction. Hence, minus I2 into R2 minus Ig into G plus I1 into R1 is equals to 0. Here Ig is equals to 0 because no current is flowing in the balanced condition of Wheatstone bridge. Hence I1 R1 equals I2 R2. From this we get the ratio of currents as I1 by R2. I2 is equals to R2 by R1. Let's keep this as second equation, and we have a equation number 1 where I1 is equals I3 and I2 is equals R4. Coming next, let's apply the same loop law for loop B C D B. Here when we apply the loop law, we get minus I4 into R4 plus I3 into R3 and plus Ig into G. Here again Ig will be equals to 0, hence I3 R3 will be equals to I4 R4. Once again we have got here negative sign because we are considering the loop in the direction of current, whereas here we are considering the loop opposite to the direction of current, hence here it's positive and in that case it's negative. From equation 1 we see that I3 is equals I1 and I4 is equals to I2. Hence the equation, this equation gets changed into I1 into R3 equals I2 into R4. From this we get again the ratio of currents I1 by I2 as R4 by R3. Let's name this as equation number 3. From equation number 3 and 2 we see that R2 by R1 is equals R4 by R3. So this is the balance condition for Wheatstone bridge, and this helps in, and it is also used for finding any one of the unknown resistance if we know all the three resistance accurately. Thank you for